So in this program, we talk about composites. So what will happen is hopefully this is kind of running. It should be running for me. But basically, composites are in pretty much everything. So you start with fibers, so dry fibers, and you add resin to them, and you make a composite. Composites are used in space applications, in aerospace applications. Also used in making snowboards and other types of applications as well. And so this program is a 9-month program where the students are going to go through 3 different types of certifications. The first is open molding. They're going to go through vacuum infusion, and then they're also going to do advanced composites. Towards the end of the program, and we'll go through some of the details on what the students do, but at the end of the program, it culminates with you learn all these different techniques, and then you build a capstone. So some of the students have built car hoods, some students have built snowboards, things of that nature. And then at the end of all of that, you go out and you get an externship. So you actually take all those skills you've learned in the classroom and you actually go out and you actually work with a company applying those skills. The really, really cool thing about composites is you can go from building from an idea on a sketch pad all the way to a final product. And so what you look around, if you look around the area here, you'll see that we have students right now are learning how to make what they call plugs. Plugs are actually a pattern. It's a pattern you make, and then what you do from there is you make a mold. Here is a mold, and then you put the dry fibers in there, and you infuse resin around them, and you make a final part. So the students are actually right now working through the process to make a catapult. So that catapult is actually a composite catapult.
They fire pretty good too.
Yeah, they do. And
so about 100 feet.
Yeah. And one thing I want to mention is I'm John Hamill. I'm the director of Composites and Advanced Technology here, and then Jason's our lead instructor for the composites program. And between the two of us, we kind of go through. I get into the classroom, kind of teach some of the theory. I was a design engineer, and I worked on manufacturing composites and automotive in different areas. And then Jason's really the expert in the hands-on manufacturing, so we kind of work really closely together to do that. Jason, you want to mention?
Yeah. So we're trying to teach the students not only how to work with the materials, but why we work with them, why they work the way they do. So the science behind it. So we want to send students off that are going to be in the industry as possible management style because they know the why. A lot of people in the shops, they just know how to do it. They don't know why they're doing it. So we are trying to teach the students to get their foot in the door a little higher up, a little quicker. So that's what we teach here. We teach everything I think you mentioned, but we open molding to vacuum infusion to advanced technologies. So the advanced technology is going to get you into, the Teslas of the world, or SpaceX, or Boeing, things like that. Or if you're into boats, we have our backyard here is full of boat companies. Bristol alone has probably a dozen boat companies that are not just building boats; they're building parts and pieces for. We have a winged, 120-foot wingspan electric Regent boat plane that is being built over here at Quonset. They just opened a factory that is going to employ 100 people. I'm not sure how many, but they're developing it in Bristol to start building them in Quonset. So that's just flies right above the water, and will eventually, I think Australia's already bought 25 of them or something like that. So they're going to use them as transport around there.
I think one of the key things,
like a bus.
Like a bus, but
yeah,
over
actually,
the water.
Yeah. So
Between the
Rhode
islands.
Island, Proterra was making composite buses. But one thing that I want to iterate with what Jason said is knowing the why is that you are more valuable as an employee if you are making a part and it fails. That's the key. We can make anything perfect. You can say everything's going to be perfect, but that's not reality. Reality is you have somebody on your floor that sees a failure and knows how to fix it. They can fix it before your engineers come down and try to solve the problem. That's the key. That's one of the things we're teaching here. Yeah, the composites are pretty much in anything, and I don't know if anybody's worked with rebar before, but this is a basalt rebar. This is actually rebar, and it's stronger than steel. And then
It's made from what?
it's basalt. Basalt is a stone.
Right.
They take stone and melt it and make it into
built out of
filaments.
molds.
But this must have air.
So these are actually vacuum
There's no air in that.
parts. So
What?
we
That's
similar
solid.
way you
Composite.
put your clothes in a bag and you
Here's
just
composite.
suck all the air out and squishes the
Yeah,
clothes.
so this
Weighs
is
on
basalt.
the same
What it is
sort of
is
style
basalt
that we do
put
with
into
these
fibers,
parts.
strings.
So they grind it down,
They melt it down and make it into filaments.
and you.
This is actually a cord piece. Paddles like
I don't know if you've ever picked up
pickleball paddles.
That's
are kind of made out of
that's
this material.
very And it doesn't corrode, and it also has the same thermal expansion as the concrete, so it doesn't
Yep,
crack.
and yeah, pass around. Build
So
bridges.
is there some kind of
You
resin
know,
mixed in
so
with the salt?
infrastructure,
Yes.
that kind
Oh,
of thing too.
okay. Absolutely. That's what it makes it look like.
So that was just somebody's project, they made a base,
Is it?
yeah, carbon fiber base, just one of them decided to make that.
Yes, yes.
Quonset,
Absolutely,
Orchard Road, all those kinds of.
definitely.
What do you shoot in the catapult?
Yesterday, we were
Tennis
at.
ball?
We go out to the wharf out there,
Yeah.
Right now.
and then the president of IYRS runs back and forth in a turkey suit. He's actually got one hanging in his closet, and we all fire golf balls at him. We're gonna try and get closer to him this year, so he doesn't have the space to get away from it. We haven't hit him yet. We're working on it. Yeah.
That'll even
One
mark.
off the leg at least, you know, I mean. So, yeah, but they do fire great, and the kids have a lot of, students have a lot of fun with them. They kind of compete against each other, who can get them the furthest, who can get more accuracy. So, it's good. It's a nice, project to just kind of get them to do the things that we're trying to teach them, and then an outcome, and, you know, not just, something that we throw in the trash.
And it doesn't corrode, so.
Anybody have questions?
Questions?
Is that your truck, car?
This was actually a past student, so what we do is this is a 9-month program. For 8 months they learn, and then for the last month they create their own capstone project. This guy decided to build a 67 Mustang hood, so he had to build a plug to build a mold, which is what he did, and then he popped this out. This is actually a bad one, believe it or not. He built another one after this, and he turned this into a business. His business is just 67 Mustang parts.
Yeah.
So he builds hoods, all the cowlings and everything for 67 Mustangs.
And he knows how to make all the way from like concept all the way to its
Yep.
part.
The other gentleman, that little piece of panel, he just decided to start building pickleball rackets. And now he has a little side hustle. On top of his regular job, he pops out a whole bunch of pickleball paddles and sells those. So, you know, you just try and make your own business out of it, hopefully. Yeah.
Wasn't there someone that designed a cast? That last year?
Actually, that was
designed a
digital
cast?
modeling.
That was digital modeling.
Yep,
But they
3D
worked with
printed a
you
cast,
guys,
so, and it had whole, you know, because you can't get in there and itch sometimes with the cast, so it was kind of made like a honeycomb almost. So she could actually get in there and scratch, you know, itch and scratch, or scratch the itch. Yeah, so yeah, and we do collaborate with those, the team next door. So somebody over there might 3D print something that we can laminate onto. So there is that possibility also.
And that's one thing as we do that collaboration between the two departments, is that they're focused primarily on design. Over here, they're focused on fabrication. So we're like, some of the students are already having a conversation on capstone of how working with the students over there to help them to design it, and they get the manufacturing folks can stand over them and say, hey, change this, change that. It's not going to be manufacturable, and then it comes over here and we build it here, over on this side. So there's a lot of that happening currently. So yeah, composites are really cool. So much you can do. I love composites. Any questions?
About your class size?
I think the most we'll probably get in here is 12. It gets a little bit, you know, need a little elbow room. But we have 9 right now. And I think the most we could probably do is a dozen in this facility right here. Downstairs, a lot more in marine systems. They're pretty loaded up down there, like 36 of them. But what you'll find is students, we just had Rupert that was in here. He went through the 6-month program downstairs, and then came up here and liked what he saw, so he now takes this semester. And then the other girl that was in here, Emily, she took composites and decided to go and do BBR next, the wooden boat building. So, and she's a sailor, so she's getting the knowledge of composites on how to fix a boat, as well as how to build a wooden boat. So she's getting the best of both worlds. So she is, you know, very valuable out there in the real world. So.
Anybody ever do anything with like a medical prosthetic?
There is that possibility. We did have a student last semester over in digital modeling that was scanning. She used a doll head, like an old doll head, and scanned the head, and then created something that you could fix a skull with. So she was kind of working with that, like some sort of plate out of 3D printing. So there's a lot of technologies over there between the scanning of something to be able to 3D print. And what we do here is we have the 8 months, and like I said, they do their capstone. So that's a big thing where they can do things like that. So
Oh, does this program have an externship or is?
it does.
Oh, it
Yep.
does.
So
And that's
8
how-
months here, and then after you go out for your externship. And a lot of the students just stay where they are. So the fit works. And that's the thing is the employer wants to keep you around as well as you want to stay. So we've been very fortunate that most of them have stayed in their positions. And I get a lot of feedback from my students. They text me, like, somebody was just texting me earlier, hey, this is what I'm doing this week in work, and, look how cool this is. I remember doing this in our class, So I get a lot of that, which is great. That's the best part of all this, seeing them, succeed, exactly. Yeah. And hopefully make a lot of money.
Yeah.
That's the key.
Like one of the things, one of the students that's in our class this year wants to do a similar thing and make a hood. I was talking to him yesterday about learning how to do 3D scanning. So using a 3D scanner to actually scan a physical part and reverse engineer to be able to create their part. So there's a lot of different tools that you learn while you're here.
Thank you. Yeah. Anybody else? Any questions?
When you're setting up like resins, doesn't the temperature have to be warmer than it is right now?
This is actually perfect. You do pre-preg, you do want things a little cooler, but that's just for the laminating part. Eventually, you put that under a vacuum bag and cook it in the oven.
Behind us.
So a little different than your open molding kind of resins, where you'll take a resin with an initiator or a resin with a hardener, and you mix them up, and then you pour it on a cloth. Pre-preg is pre-impregnated from the factory with resin and hardener already in the material, and then that comes in a frozen state on a roll. We keep that in our freezer over there. We take it out, it can be kind of cold still, we lay it into the mold, we vacuum bag it with our vacuum bag stack, we put that into the oven under vacuum, and that cooks and, coagulates and,
So
gets
what's
all
the
together.
temperature in there?
We get up around 200, 250-ish, yeah.
So
Yep.
very.
It goes up in
very
stages.
fast reactions then.
Yeah, it's a 6-hour cook maybe, depending on the thickness of the material. Or sometimes some of the molds need to get heat inside the molds. So it might take longer, so you might have to dwell, go up to 85 and dwell for a little while, then you go up to 100 and dwell. Kind of gets the temperature all rising up,
That's really important.
cooks, and then starts to dwell back down again.
It's part of the chemical reaction.
Yep.
Absolutely.
Yep,
It's
it's
a very,
all
very
science.
critical part. And that's one of the things we teach the students is both the how and the why.
Do you need to have a very strong understanding of chemistry coming in? Like-
Nope.
Nope. Not at all.
We have students that show up that don't know how to work a drill. So we teach them everything. We teach them how to table saw, chop saw, how to work a drill, everything you need to
Yes.
work with your hands.
Yeah.
And literally, people have not known how to turn the drill on or put it in
Yeah, we
reverse.
just teach them
And
from
we
that
teach
all
them
the
all
way
that
to
stuff.
making their own parts. Yeah.
Yep.
And from a chemical perspective, there's a limited amount you need to know and to ensure that you just walk through a step process on how to cure. Understanding how the cure process works, we work through that, but you don't need to get into in organic chemistry or anything of that nature at all. It's more of like, okay, here are the chemicals, here are the type of reactions that are occurring and why it shrinks and why it does what it does, and why it's super critical that you follow the cure cycle properly. Because the part might look great, but it's also might be a bad part because you cured it incorrectly. So, yeah.
Are we over? We're over.